Hello guys, welcome to another YouTube tutorial. So in this tutorial we're going to discuss about RANSAC regression method. So this is one of predictive machine learning technique. So that's how we call it. So it's a predictive machine learning technique, but so RANSAC, what it is all about. So we're going to see that. So before we go into that topic, I want you guys to like my Facebook page where you could keep yourself updated about the recent happenings on my YouTube channel. So and also subscribe to my channel, like my Facebook page. Link to this will be in the description. So now let's jump into this one. So we will be using this housing data, Boston housing data from this link. I'll put the link to this link in the description. So here you could find the Boston housing data for different Boston housing price data for different criteria like number of rooms, the locality, neighborhood, and all those. So those criteria plus what's the price. So that's the data that we have here. And then we're gonna apply RANSAC on this one, and then we're gonna do a simple and compare the output of RANSAC regression model with the output of the linear regression model in terms of graph, and then see what's the difference. So that's the objective. So let's get straight into this. So before we go to the code, so let's see what this is all about. So the cool thing is I bought this cool stuff where I could scribble down my notes so that you all can understand this better. Okay, so this so let me explain. This is a simple linear regression. Okay, this is simple linear regression. So you have x, and then you predict y based on the previous history. You do the future forecast. So you calculate the slope here based on your training, and then you fit. I mean, you play with your slope by testing it. That's called training. So you fit, train, adjust the slope, and then do predictions in future. So that's what simple linear regression is all about. So let's take a case that you have outliners over here, over here, over here. So let's take a graph like this. So these outliners actually squeeze your graph, but the majority of your data are here. But this actually squeeze your graph. I mean squeeze. It just takes you away from the actual output. So how to deal with these kind of outliners? So linear regression can't deal. You have other statistical techniques that you could use to deal with these kind of data, but you have this RANSAC regression method. So you could use that to get rid of the outliners. So what's actually happening there? What's actually doing? So let's say you have a graph like this. So let's say you have 1,000 data set. So it takes 50 random 50 of those data set. Then it's gonna construct a graph. And then it's gonna test those that graph, the equation, with the rest of the data. So and then before you go ahead and do that, you have to specify your inliners. So let's say in this case, you let's say you plot the graph with what you have, and then you specify your inliners. Let's say these are all your inliners, and then these are all your outliners. Okay, so you specify the inliners, so you automatically get your outliners. So just like this case, you specify the inliners to data that falls within this line. So let's say I am ready to accept the error of plus minus 5 with respect to this line. Okay, so it depends. Let's say I want only like plus or minus 1, then you can go for that one. It's not a problem. So you specify this one. So like what I've said, it's gonna take random 50 data from here. Then it's gonna fit this graph, and then it's gonna compare this one, this one, with the rest of the data. If those data falls within this inliner range that you have specified, it will consider those data, it will refit the graph again, and then it will test again. It will do that till the number of iteration that you're specifying. Okay, so that's what it's going to do. If there is any outliners, it will ignore, it refit the graph again. It will test the error. Let's say, I mean, yep, like what I've said, it will test the error, it will refit the graph again. So it will repeat that till the number of iterations that you specify. So I want this to be performed 50 times. So it's going to do that for 50 times. Then it's going to fine tune your graph accordingly, and then it will eliminate the effect of outliners from your model, predictive model. So this model is quite fine, but it won't be effective on data sets that it hasn't seen. Okay, so that's where the disadvantage of this model lies. So now we get an overview of what this is all about. Let's do the coding, the fun part. I don't want to save this one. Don't save. So let's go here, and I also like pictorially explain what's happening here in this code. So the new graph, I put this here. So these are all the columns of the data set that I've shown you guys before. So I bring in, so in order to activate df.columns, I need pandas. So import pandas. Paste. And then, so df.column, I'm just specifying it. So df, I'm actually have to read the data from the link. I'll put the link in the description. pd.read csv. CSV is the file format. Comma separated variable, if I'm not wrong. Okay, so I get the data, I store it on df, and I'm saying that each and every it will recognize the columns accordingly, because the format tells the data frame how the data is structured, but it doesn't know what each and every single column represents. So that's what you're saying here. Okay, so from that we take x and y. We're not going to use all those because it's a linear regression technique, similar to the regression. So x is number of rooms, and MEDV is your price. Okay, so this is what you're going to predict based on the number of rooms. So yeah, let's draw that out. So rooms, MEDV. So you're going to predict, as logically, if you think the rooms go up, the price goes up. So that's what this is. It's going to be sort of like linear regression, but we're going to like take care of the outliners. So that's what's going to happen here. So now we got wait. Sorry for wasting your time, guys. So now we got x. We got x. We got y here. Okay, we bought them in. Actually, we could plot it. So now we're gonna do a fitting. So in order to do that, we have to import RANSAC linear regression. So shit. So we brought in the values and we're gonna fitting the values to the RANSAC model. So before we do that, we need to import the RANSAC regression model. Oh boy, this is huge. I'll explain this. Okay, so now I go to edit format. Where the heck is that? Options, configure ideally, size, then bring this down to 14, apply, okay, and then I maximize it. Still, you don't get the complete picture. What the heck? Okay, I'll just. Okay, now you get the complete picture. So, before I do this, I have one more step where I say import blah blah blah. I missed it out where this import ransack regression. So as you can see, the code is like a few lines of code, so it's not. So we get to understand this better. So ransack regression. So I've imported the model. So now I'm passing like declaring the function. No, creating an object of the function ransack regression, which is the object name of the object is ransack. You could call that anything you want. So linear model dot linear regression. I'm calling linear regression. Perform ransack model for linear. Uh, Apply ransack technique for linear regression. That's what it's about. So the maximum number of trials, it's going to do that for 100 times. The minimum number of samples, it's going to take 50 samples. So residual metric lambda. What does it mean? It's the difference between the fitted value and the actual value. So it's going to check that one. It's going to like adjust it accordingly. So what kind of is it using? What kind of averaging it's used? It's going to like use numpy.abs. Okay. Then the axis, it's okay. So axis refers to like which axis is x, y. So okay, that's what it refers to. So you could just you want to know what, just go ahead and check online so you can find it out in NumPy. Okay. Residual threshold. Residual threshold is like the plus or minus 5 in this case. So you could specify that whatever you want, and it's application specific. You can't generalize it. So that's one of the disadvantages of this one. So the random state is 0. So now we are pretty much there here making sense out of what this model actually needs, so that we could create an object of that model and then apply them on a data set. So now like we are pretty much there, we call the model and we and fitted the model with the data x and y. So x is number of rooms and y is the price. So I go back, configure my ideal, integrated learning ideal, integrated development environment ID, learning environment, whatever it is. So apply, okay. So now you could see it. Now I take this there and then I'll bring back my source code, which is here. So I fit the model. So I'm gonna call the linear mask inliner mask inlier mask inliner. So that's what it's referring to actually, inlier mask equal to ransack. Use this one, so you could call this name this anything that you want. Outlier mask is like not of inlier mask. Okay, so it's actually a boolean, not simple as simple as it. If it's 1, it's going to convert into 0. So it's a logical not. So don't confuse yourself very much. So I'm going to create an numpy.range. So if you have no idea what that's all about, so do a simple thing: print line x So then even I don't know, so I just print it and see what the heck. Linear model is not defined because I have to call the linear regression here. So where is it? I got it. Okay. But let's see. You keep doing it. Every error that you see, you know the solution. You don't have to go into detail. So you just keep doing it, and then you'll become an expert. So I have to bring in NumPy. Import NumPy as NP, and then I have PD. So when I plot the graph, I need matplotlib. So now it's actually we want to see. Yep, this is what we want to see. np.range from 3 to 10 with the increment of 1. 3, 4, 5, 6, 7, 8, 9. Okay, so that's what this thing does. So we get rid of this one. So we don't want to see it again. So now we know what it's doing. So you are creating line 1. So you are predicting y with respect to x. So that's what's happening here. And where are your x? Your x is here. You are defined here. Okay. So how many times it's going to happen? It's going to happen for 100 times. That's what you have specified here. Number of trials. So it's going to grab 50 from your overall data set, and it's going to do the prediction for 100 times, and it's going to fit its slope accordingly. That's what's happening, to put it simply. So now I go, I have predicting my y, and then I'm going to do a scatter plot. So I bring this line in, and then I explain first, and then I bring the next line. So the scatter plot, it's going to have x values which are inliners, and y value which are inliners. Only it's going to take only the inliners. And then it's going to like color it in blue. It will be like I mean the data point will be marked in O, and then it will be labeled as inliers. Okay, so you do the same for outliers. Copy. Paste. This is actually one of the predictive modeling techniques. So yeah, so the outliers are going to be in light green color. It will be like X marked, and then it's actually labeled as outliers. Yes, in the sense it's referring to X. I'm not sure. Let's plot it out and see. So it's going to plot a line, and then we give it a label. So first, before we go for the label, let's just show the graph. So before I show the graph, I have to import matplotlib.pyplot as plt. Boy, you're here. I don't know how many minutes have elapsed since the beginning of this video. So it has to print it out for us. If it doesn't, there's an error. So like just like what I've said, so let's maximize this. So these are all your outliers, like what they call. These are all your inliers. Okay. So now we go. Let's go ahead and give the corresponding labels. Brother. So these are you specify where the legend should be located, and then this is your x-axis label and y-axis label, and that's all. Those three lines of codes goes before plt.show. Save, press F5, so you get your output. There's a depreciation warning. Take care of the warning. So your blue represent outlier. I mean inliers, and green represent outliers. So this is what? Yeah, you have this graph. This graph has modified itself based on the inliers, outliers, and the threshold that you're specifying. This graph is a graph directly from the linear regression. So if you see the slope, it's different. So if you see here, it just goes straight on to this data point. In this case, it just bends down. So what are we gonna see? Let's save this one on desktop. So let me call this figure 2. We'll save this. Now I get down to this one. Where is my code? Here. So I'm gonna play with the lambda. I mean, not actually the lambda, the real threshold. I'm gonna give it a 10 and see the effect. So it's actually gonna like execute. It's pretty much the same. It's pretty much the same. And okay, let's make this one. Let's see. There's nothing wrong in playing, right? So just play with the data. Holy crap! Now you could see the effect, bro. Now you could see the effect. So this is for one threshold. This is for no threshold. So you could see the effect actually. And then this is 5 threshold. Wow, 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 very nice. Awesome, ain't it? I think we are to the end of the tutorial. So thanks for watching. If you guys have any doubts, comment below. If not, subscribe to the channel, like my Facebook page, and see you guys in the next video tutorial. Thanks for watching. Bye for now.